Welcome to the lesson on 17.3, using a Pythagorean identity. Essential question is, how can you use a given value of one of the trig functions to calculate the values of other functions? Well, before we could do that, we should probably state what a Pythagorean identity is. So, otherwise known as Pythagorean Theorem. Actually, most books call this Trigonometric Pythagorean Theorem or identity or property. Okay, so before I could do that, I probably should do a proof, right? This is a unit circle, but I want to use like any generic right triangle. So I'm going to extend this a little bit and pull it down. These two are parallel. And let's call this some x value. And let me call this some y value. And this is some radius r. But because the reason why it's called Pythagorean theorem is because when you have a right triangle, we know that the x squared plus y squared is r squared by Pythagorean theorem, PT, right? And then what we're going to do is we're going to divide everything here by r squared. When you do that, it becomes x over r squared plus y over r squared is equal to 1 by simple algebra. So what we're going to do right now is to apply the definition. See, when you have a theta here, guys, when you have x over r, that's adjacent over hypotenuse, right? A little bit of review. SOHCAHTOA. We learned SOHCAHTOA, then we convert it to using coordinate trigonometry, and all it is a sine is opposite of a hypotenuse. It just happens that the opposite side is always y value, right? So sine is actually y over r, and cosine is x over r, and tangent opposite is always y, and adjacent is always x. So we have y over r for sine, x over r for cosine, and then y over x for this. So I guess if I have to make my own, this makes actually no sense at all. Sir ticks, I guess, okay? Well, anyways, this thing that we have over here comes from SOHCAHTOA. So when you have x over r, with respect to this angle, the central angle is cosine theta, and y over r is sine squared. Oops. Squared is equal to 1, but more commonly we tend to write it this way. So we write sine first and cosine. I don't know why we do this, but my best guess is that putting parentheses every time is, kind of long, and then putting a square on the outside is confusing because it looks like you're squaring the angle. We're not. We're squaring the sine of the theta, so we tend to put the square inside. So this actually means this. It actually means the same thing. Okay, so we have this, guys. This right here is what we're looking for. That is the trigonometric Pythagorean identity, property, theorem, whatever you want to call it. Okay. As long as it has the word trig and Pythagorean, and what comes afterwards, generally identity, property, or theorem is okay. Okay, let's do an example, shall we? Okay, knowing this over here, they want us to show that it actually works for the following angles. Okay, let's take a look. As a part of the review, and it's good habit for you to just draw a unit circle, or any circle for that matter. And pi over 3 is, we should be thinking as soon as we see that, because pi is 180 degrees, divided by 3 is a 60 degrees, right? As more you do this, you don't even have to think about that. You just know that pi over 3 is just pi over 3. That's just 1/3 of the 180. So it should be about here. Divide 180 degrees equally, pi equally, and that's about it. That's 60. So when you do that, so you're thinking that's a 60 degrees, and that must be 30, if this is a special triangle, right? If it's a unit circle 1 over here, then this opposite side is half, and this must be root 3 over 2. So always try to keep this unit circle in mind. Okay. If you wanted, you could also use 2, 1, root 3 instead. It will still work. Now, idea is to show that sine square of pi over 3 plus cosine square of pi over 3 is in fact equal to 1. But once again, this actually literally means this. Going forward, you don't have to write it this way, but for now, it might be a good idea to write it this way as a reinforcement mechanism. I wrote it slightly differently. It really doesn't matter if you have parentheses here or not, so I generally do not do that. Okay, so what is the sine of pi over 3? Well, as we learned in the past, right, that's a little bit of a review. Once again, it's that when you have sine theta, we know that, we know that it is y over r. But in a unit circle, r is equal to 1. So that's y. So sine theta just represents the y coordinate of a unit circle. So that is equal to root 3 over 2. And then can you guess what that says? What is cosine of pi over 3? Okay, if you said cosine of theta is x over r, and in a unit circle, r is equal to 1. So basically, it is the x coordinate of the unit circle. In this case, it's 1/2. When you square that, that's 3 over 4. When you square that, that's plus 1/4, and that is equal to 1, right? So you could claim that therefore, sine, this is by transitive property of equality, right? That is equal to 1, hence theta equal to pi over 3 is true when used in Pythagorean Trigonometric Pythagorean Theorem, TPT. All right, let's go with that. Okay, guys? All right. Let's do one more. This will be the finding the value of other trig functions. That was the second part, wasn't it? So we're now answering the essential question. How do I do that? Well, given that this is true, where this is true, so we need to be very careful. What is this saying, guys? This is telling us that the angle is in which quadrant? Quadrant 1, right? So if you draw quadrant 1, and we learned earlier that sine theta is y over r. But when r is equal to 1, we know that sine theta represents the y coordinate of a unit circle. If it's a unit circle, that's 1, and that is 1. And if my y value is 0.635 in my first quadrant, that's a half. Well, it's about here, guys, right? Because that's when y is equal to 0.635. And where does that intersect in the first quadrant? It's right there. So that's the theta that we're talking about. Okay? So we see that because of that, because it's more than 45 degrees, my y value appears to be a little bit more than my x value. It's hard to see, but because my circle is not exactly perfect. So you know what, guys? Why don't we just use this formula that we already know? And we're looking for what? Cosine? And you can solve for that first, but you know what? Let's plug it in, see what happens. 0.635 squared. To solve for the cosine, we need to move this to the other side, right? But that's cosine squared theta. To find cosine theta, I square root both sides. But the question is, do we still put plus or minus or what? We know that all students take calculus. Because this is in first quadrant, every trig function is positive. So we're going to stay with positive, right? It's not negative. So what do? Well, I'm going to put that in the calculator. Okay. When I did put that in the calculator, it came out to 0.7725121358. Just write it all out, okay? And then we could state that cosine theta is approximately, because this was given with a 3 decimal values, guys, to the thousandth, we should do the same. Okay, that's generally the convention. So we round up, so it's 0.773. Now we still have to look for the tangent, right? So what is tangent, guys? By definition, right? Sine theta of cosine theta. Sine theta was given to us exactly, right? And the cosine theta is right here. So what I want you to do is, once you put it into the calculator, I want you to use the exact value. I don't want you to approximate it. And to show that to you, here it is. So once you found that is a square root of 1 minus 0.635 squared, we got this value here, right? So all you have to do is to find that is 0.635 divided by the answer. So to get the answer, all you gotta do is second and hit entry, right? And press enter, all that. I'm just gonna copy that over, guys. That is equal to 0.82199355591. And to state the answer, tangent theta is approximately to the thousandth, 3 decimal places, is 822. Right? So therefore, I'm going to say that those are my answers right there. Okay? Alright guys, that concludes today's lesson, and we'll finish the rest in class. Alright guys, have a good night.